So, hello everyone. My name is Athina Bosta, and today I'll present our work on UserSense, a multimodal approach to user experience evaluation. The reflexes. Our research explores how combining physiological, behavioral, and contextual and self-report data and how they can provide a deeper understanding of how users interact with systems. User experience evaluation traditionally depends on what users say about their experience. Don't mind the sounds. However, self-reports alone can miss critical information as they are subjective. Physiological signals, and thank you very much for being the last presentation in this session, because you understand how physiology can translate to many things, about the eye and everything before. Thank you. And physiological signals like heart rate or brain activity reveal responses beyond conscious control. Combining multiple data types helps us capture a more complete picture, we can say. To address this, we developed UserSense, a tool that integrates data from multiple sources into a single timeline. You can see the timeline, the visualization up here. It gives evaluators a holistic view. This is what we came for. The description, holistic view of the user's experience by combining objective signals with subjective reports. UserSense is composed of four main components. The mobile app collects self-report and contextual data. You have the questionnaire there. The analysis component processes all signals and extracts UX-related features. And then the visualization app tools displays them, as we saw beforehand, on a single timeline. Finally, a handbook supports evaluators through step-by-step and the analysis and how-to guide, let's say. I like to say that. The typical workflow includes 4 stages. First, evaluators prepare device and scenarios to select the type of evaluation, etc. Then participants complete the tasks before the baseline, of course, after the baseline, sorry. And then complete the task while physiological signals and behavioral data are recorded. Next, data are processed. For example, peaks of NDA indicate emotional arousal, while HRV reflects, for example, stress. Finally, results are visualized as an experience chart. We conducted the 2 pilot studies on a real-world setting and 1 in the lab. We also evaluated a collaborative design game. You don't see my video playing, right? I can just play. Great. Oh no, I missed my notes. Now go to work, thank you. We also evaluated a collaborative design game. We learned that data quality depends on equipment type and usage conditions. For example, certain EEG headsets were more reliable and participant behavior, like they're not that reliable, whatever, like movement or use or hair products. I didn't know that. It was very interesting to know that. You can use hair products when you're evaluating with BCI devices. And it could impact results because such participants had to be excluded for the BCI usage, for example. We also observed that physiological data is most informative when the activity elicits strong emotional responses, such as gaming or VR experiences. Controlling external factors and selecting participants carefully are crucial to reduce noise or ensure reliable data. Because we work with sensitive physiological data, ethical considerations are essential. Participants must give informed consent, data must remain secure and anonymized, and evaluators should understand the emotional models underlying the data they collect. In conclusion, a physiological, behavioral, contextual, and self-report data gives us a richer understanding of user experience. UserSense helps link emotional and cognitive responses directly to, let's say, design elements. Our next steps is to include larger studies and refining the methodology to improve reliability. And that's all for the UserSense. Thank you so much for your attention. This project was supported by the Heritage Initiative under the Horizon program. Heritage is an European-funded project, and we're part of a toolkit. This is why I stop here for UserSense. Thank you very much. I can take my questions now.
Hello, Chris Hatsanos from the Aristotle University. Thank you, Athina. I think your other role made you too much speed. you finished in like
Yes.
5 minutes.
Sorry about that.
So I want to give you a chance to elaborate a bit more on the tool, because I actually didn't understand the interface of the tool, of the UserSense tool. Basically aggregates the data, or it does some types of combinations, new metrics, new visualizations. I didn't get that, to be honest.
Thank you very much for the question. So basically what we did, and this is why I have the FYI screens, is that we have different scenarios per evaluation. So different devices are included, and you have to gather the files. And what you do next is that you have a source code, the analysis component. You run this analysis source code, and then you have another file, let's say, which shows up when you run the visualization app. This is an executable file. Then the timeline shows up as they show in the video. Did I answer your question? I was too fast again. No, we have selected specific metrics, and we have combined many insights of what kind of metrics physiological responses produce, and we did the match. For example, we selected HRV for stress, or arousal for attention, or different data, different metrics on the timeline.
Sorry for taking the time. Thank you, Christos, for your question. May I add a small comment to that? Well, actually, yes, we received the input of the various devices, and then there is an analysis phase. But the analysis is based mostly on libraries that are already existing. So, for example, we analyze EDA signal in terms of attention, or heartbeat variability in terms of stress, or we take the already analyzed data from the EEG, which analyzes them in terms, again, of attention, enjoyment, and so on. So we aggregate all this data in a single timeline, so that when you move the timeline, you can see what the user is looking at, because we are using in external evaluation some headcam, where he's located, because we have also GPS coordinates collected through the mobile device, and how his emotions, as analyzed by the different signals, are fluctuating. So this is not, of course, 100% correct, because there is noise, there are troubles, but we believe that triangulation, looking at multiple signals on the same timeline and trying to understand the context of the interaction, helps us to give us some insights on typical usability issues, or maybe user experience peaks and issues. So this is the idea behind this. Sorry for intervening, but...
Just another comment about that. There's a challenge about deciding which data processes we should select about analyzing the data. It's another field of research, I guess. So it's a great challenge for us to decide which one we collect, we include, and then visualize.
Just a very quick one. I'm not an expert on experimental research, as we do a lot of in situ research, but I know that there's a lot of commercial products out there. All the companies who actually provide the lab equipment and all those other companies, I think they have their own software, which usually is very expensive. So is this going to be open source? Oh, perfect, great.
Thank you very much. It's an open access for starters. There's another challenge here. Not only we don't have the raw data, but sometimes you have to pay to take the raw data and to pay to get the wearables too. So we're bound to many policies there. So we created a tool to be open access to the public.
Thank you very much, Athina.